Okay, so let's get started on the first one, non-conscious behaviors and neural activity in the normal people. Um, let's get started from the reviewing the backward masking. So here's the example of the backward masking. And if it doesn't work, then I recommend you to play it again on your browser. Okay, initially you see A without mask, and you don't see it with strong mask with brief interval, and then now you start to see something before the mask, and then I hope most of the people start to see E, and then here it's N, and so on. But if you stop the frame at some point, then you see that A was presented in this frame, and then even at this very fast one, you can see that it was presenting K before the mask. Okay, so the backward masking is a phenomenon where you are shown briefly very brief stimulus followed by strong high contrast stimulus following afterwards, and then the things that comes afterwards erase the conscious experience of the first, and then you see only the mask. That's the basic phenomenon of the backward masking. The study that we are going to take a look at in detail is the study done by Stan Dehaene roughly 20 years ago. This is a masked masking combined with the neuroimaging, fMRI and EEG, as well as some behavioral testing. So that's a very good study. Okay. And as you will see, Stan Dehaene has since then proposed a particular theory called the global neuronal workspace theory, which is something that we will discuss this lecture towards maybe 2 to 3 weeks from now as a sort of the guiding principle of many of the consciousness research right now. It's one of the most strong proponent, so the strong theories available right now. Okay, so in this experiment, there were 4 conditions in any given trial. Okay, so this is very, in a sense, complicated design, but you need to understand it, 4 conditions. 2 conditions are this visible word or visible blank condition. And in this condition, they use the masking, but not only the backward masking, that is meaning that some kind of target presented and afterwards there is a mask. Okay, not only that, they also presented forward mask here. So the perception here is that you see a bunch of meaningless things, symbols, followed by the blank of 71 milliseconds. Then in the visible world condition, you see lion or some kind of other letters in French for 29 milliseconds, followed by nothing again, blank, and then mask. So this is a visible world condition. Visible blank condition is mask, nothing, and then mask. Okay, that's 2 conditions. Third condition is a masked word condition. And here, first forward mask is followed by nothing, then mask, then stimulus, then mask, and then nothing. Okay, so this means that there is some kind of mask that becomes transiently invisible, blank, and then mask, and then instead of becoming blank, transiently they show the stimulus and then followed quickly by the mask. And then this so-called sandwich masking turns out to be very, very strong. And so that because of the combination of forward and the backward masking, and this is very, very difficult to see. Anything is invisible. And then, so instead of showing any target, they also included a trial where nothing is presented, blank is present. Okay. So there are 4 different conditions in this experiment. Now the behavior result. The first one is the experiment conducted before the fMRI experiment. So subjects are presented on the display, and then watching a continuous stream of 37 visible words, and also 37 masked words, and then 37 control blank trials. And then all of them are appearing in the random order. And then each of them are separated in 2 seconds, okay? And then whenever, wait a sec. So just to make sure, 37 trials, and the 37 trials, and then in a random order, and then with some interval. And then within this first experiment, when they thought that word was presented in that interval, within this 2 seconds interval, they are asked to name it aloud. Okay? And then if they felt unable to name it, then just say no. But that if they felt that they saw something, but they couldn't name it, then they would just say that, oh, I saw it, but without any identification. So it's one particular experiment with 2 potential response. One is that, naming, oh, I saw note, lion, and so on, okay? Or I couldn't see it, but I couldn't identify it as a particular word, but I saw something. So that would be good, the seeing in French. Okay, all of these verbal response is going to contaminate the response in fMRI. So they just did it before fMRI, outside of the fMRI scanner. And then the result is the following. So this error varies across subjects. Okay. In the visible condition, then they said that either they identified the word, so this is a word naming thing, which is this performance, or a little bit of seeing response, and this is relatively a frequent finding, and some of your journal club paper might touch upon it, but in general, when people see things, they are also usually able to identify things. And in the case of the word, that's the case. So they see it, and then they are able to identify it. That's the visible word condition. And then the masked condition case, almost 0%, they even detected and also couldn't name it. And in the case of the blank, this is a sort of the control for the false alarm rate. Even though nothing was presented, somebody might say, oh, I saw it. So, but in this case, almost nobody, or in no trials, they reported this, false alarm. So this is the first important, 2 measures of one experiment of the behavior, okay? So now going to the next. And then after fMRI session, so fMRI session is going to be just passive viewing of those 3 conditions or 4 conditions. Visible word, visible blank, invisible masked word, and a masked blank, and then repeated many times. Okay, and then participants were shown again with each of the 37 visible words, and then and 37 masked words, and then 37 distractors that had never been presented before. Okay, that's the program. That's an important thing in a random order. And then here they excluded the possibility that things were just invisible because of too short duration. So here they showed it all unlimited time. Okay, so then they decided whether or not what had been presented before, or meaning before that experiment, fMRI session. Okay, and so then what they reported was that okay, in the case where people were shown both lion in the visible world condition, in the pre-fMRI condition, they would say, oh yes, I saw it before, and that accuracy was quite high, like 85%. And then in the case of the masked word, like lion, that's very low, like 2 to 3%. So presented as a masked word, which was not visible, in the first place. It was also reported later on. No, I saw it, very low probability. And then distractors, such as, let's say, mountain or turtle, which was not presented in the before fMRI experiment, that was also reported as seen, but at the same rate as this mask. So this is very important. It measures the catch trial performance. Okay, and then after all of this, further experiment happened for the forced choice experiment. That's also important. And then the forced choice experiment, each of the 37 trials, first they show this brief things like either masked word or masked word or visible word. Okay. Sorry. In this case, actually, it's always a single masked word. So it's mask, blank, mask, then followed by a short presentation of the word, and then directly following mask, and then blank, and then mask. And that's one chunk of that single string. So right after this single short string of the masked word, then participants were told about the presence of the hidden word. So they were told always, actually, there is a word. And then asked to select among the two choices presented at the left or right of the fixation. So they would be shown very briefly lion, mask, and then on the left side there is a lion, on the right side there is maybe turtle. And then you choose which one was presented just before. So there is no memory confirmed here. And then the performance here is a 50% chance. Okay, that's the third and fourth measurement of the behavior measure of this experiment. So now I'm going to go through this all the four results using a signal detection terms. Okay, and this is let's focus on this visible word condition. And the visible word condition, you can use this visible performance and also blank performance as a false alarm and also hit rate. So here, hit rate is 90% and the false alarm rate is almost 0%. So it locates around here. And that's more like D prime of 4 or area under the curve of 1. It's a perfect performance. Okay. And then word naming case, we don't have that similar kind of measurement. So we'll just remove or ignore for now. And then now the recognition memory performance. So here, the performance of the correct hit is slightly lower, like 85%. And then there is also a little bit of the false alarm on the distractor. So there is going to be false alarm a little bit to the right. So that compared to the blue, it degrades to the right. So D prime now becomes 3 or area under the curve lower than 1. Perfect performance. It's not perfect. Okay. And then let's come back to the masked version of the performance. So masked version, we have 0 hit and so 0 false alarm. So it's here. And this is actually ambiguous. Ambiguous in the sense that, if you have an extremely high threshold, you can't tell whether this point is consistent with D prime of 4 or 3 or 2 or 1 or 0. So this itself doesn't say anything. Okay. However, the recognition memory starts to tell you something a bit more. So here, masked and the distractor had a little bit of the hit and this little bit of the false alarm. So this is, around here. But important thing is this forced choice performance. Here, the masked stimulus was always presented. And then half of the time people said yes, half of the time people said no, corresponding to half of the time hit, half of the time false alarm. And that locates in here. And that unambiguously makes it possible to, for us to conclude that masked performance is D prime of 0 or 50% area under the curve. That is the chance performance. Okay. So under this condition, what we can say is that there is no there is no dissociation between the phenomenology and the behaviors. So when they say that they saw it, the visible, through the verbal report of seeing, oh yes, lion, no, and so on, here the performance was also perfect. Okay, so participants phenomenally saw the target and performed very well in the visible condition. And then if it's strongly masked like this, then they also do not say that, I saw it. Okay, so they deny seeing, and also the performance was also a poor chance. So there is no dissociation. However, there is the reason why this paper was published in Nature Neuroscience is that it is very interesting in the several ways. So here they use fMRI, and 2001 that was at very cutting edge kind of situation. Okay, and then their ingenious idea was to compare this neural response using the comparison between not only the mask itself or visible world itself, but the subtraction between this pathway, visible and present, minus visible absent, this pathway. And then that they define as the response to the visible. And then in a sense, they subtracted out the neural response caused by this or transients between this, mask and not mask offset or mask onset transient. Okay, all of these are assumed to be equal, and then they subtracted. And here again, masked present minus masked absent. This pathway minus this pathway was subtracted, and then that's called masked response. And without doing this, if you were to do this visible present minus masked present, the problem is that the condition between this or that is not equated physically. So this is a kind of a thing that is very important for the neural correlates of consciousness. We are going to talk in from the next week and so on, that we want to minimize the physical distance as much as possible, but extract the largest subjective difference. And here's the one way of doing it. Making sure that many things are equal between the control condition versus critical condition, and then generate the largest difference in terms of the subjective experience. You might say that, in the end, if you do subtraction like this way, still there is a huge difference in terms of stimulus difference, but that's not, that wasn't sort of too critical to be rejected in that time. And now it's criticized quite a bit in the literature, but this is still a great paper on its own. Okay, so now after doing this double subtraction, what they found was that first, in the case of the visible world, they generated, first of all, lots of visual cortex activity and also parietal cortex activity, as well as the frontal cortex. This is frontal, this is parietal, and this is the visual. And these are the glass brain, so sagittal slice, and then finding that the largest response is this, fusiform gyrus or world area we are going to talk about next week. And this is the horizontal slice at each of this height. And then you see all these different level of the activation encoded in this p-value. So the p-value of red here is extremely significant, red one. And then purple one is weaker. Okay. And then if you focus on this fusiform gyrus response and then make a time course of this subtracted, presence minus absence, what you see is that the bold response signal increases like around 5%, up to 5 seconds, up to 2 to 3, 0.2 to 0.3% increase in bold signal. It's very significant and strong in terms of the fMRI literature. And then in the case of the masked word, they found this visual cortex and a little bit of something here, but it's not significant. Here, the p-value is much lower. So, 0.02 is in fMRI literature considered as just a noise because you're measuring many voxels at the same time. But around here, the word form area, because this area is same location as the visible world condition, we had a prior hypothesis that we should see something over there. So relatively weak activation here should be considered as significant. And something like this, we might talk in the later lecture, a bit of the statistics. But anyway, so this is considered as significant. And the time course of this word form area for the masked word condition, again, it's a subtraction, not the masked word response itself, is above chance here, above 0. Okay. So just to give you a bit of the clearer view. So here's the magnified version. So this, fMRI response shows some delays since the time of the onset of the stimulus. It peaks around 4 seconds to 6 seconds, and that's the case here. And here, the response is about this, first form area. And then non-conscious is above, 0, very, okay? So that's the upshot of this paper, most important finding. But you might ask, so are these weak activation real or not? In the end, the behavioral experiment we first reviewed very carefully shows that, subject denies seeing it, first of all, and then the behavioral performance also showed that it's completely chance in the forced choice, task. So why do we need to believe that this is not a noise, or maybe the leftover of the activation from the, visible condition, which is still the case, but, we don't talk much in the lecture. So to back up this claim, they did the same experiment, but using the EEG. And in cognitive neuroscience or consciousness research in general, this type of convergent evidence is always important. And that's why I ask you to do this journal club and then look at the same kind of phenomenon, but similar across similar studies. Every study changes slightly different kind of conditions, but if the measurement or conditions are still pointing in the same conclusion, it's likely that we can believe it more. And here they did the same experiment using this, sandwich masking of 4 conditions: visible and visible blank, masked present, masked absent, and then subtracted, and then show this, EEG in time over the time. And as you see, the response location is quite blurry here, okay? And that's what I told you in previous weeks. EEG does not have a very good spatial resolution. But what it has is this, a very good temporal resolution. So here you see that the peak of the response is here in the case of the visible. First, roughly visible visual cortex back of the head in 156 milliseconds. Okay, visible present minus visible absent shows the biggest response around here, and then the second peak comes here, and the positively and the negatively here, frontal and the back around 244 milliseconds. Okay, it's a millisecond both, and then finally 476 milliseconds. Well after things disappear, and people are probably trying to make sense of what it was. Parietal areas tend to have a very strong response. And in the case of the masked condition, masked presence minus masked absence, you see very similar level of activation, or the pattern of activation, but the units are different. So this is plus 0.6 microvolt, and this is plus 2 microvolts. So it's roughly 10 times, 3 to 10 times bigger difference. But around the same time, 172 milliseconds. Okay, so this is roughly the same time, and around the same time, but now 244 milliseconds, then this becomes pretty much like noise. You don't see very strong activation. And then same goes for 476. There is something, but it's much weaker. Here it's a 3.5. This is 0.6. Okay. And the probability or the location is not that same here and here, and then here and here. So their claim is that initial response at 172 or below, it's weaker, but the topography wise it's similar and also significant. So here the claim is that if you use EEG instead of fMRI, we can see a relatively reliable activation by the masked words in the beginning of the trial, which dissipates very quickly. And that explains why fMRI response is so short, so weak, but located at the location of the visual cortex. Okay. But still, the conclusion that we can make from this experiment is that the masked words does seem to elicit a very weak response according to fMRI, but in the same location. And then according to EEG, it is a activity that is very short-lived. And by the way, we will discuss the implication of the visible model condition in the later weeks in effort to explain this global workspace theory of consciousness. But here this week we focus most on the non-conscious activity and non-conscious behavior. So we are going to focus on the masked words, and that's basically very weak and short-lived. And the question for us is that whether these types of the weak and short-lived response, is there any kind of the behavior meaning for that? And according to Potask, again, the answer is clearly no. The weak and short response does not have any behavior meaning. However, these people, Deheng has been very famous for working on the priming. And priming is supposedly one of the most sensitive and specific way to tap onto this non-conscious process. Okay. And the idea here, or theory here, is that the so-called repetition priming paradigm or repetition priming experiment can activate the same area of the invoked by this non-conscious stimulus, and then it can activate such area before the effect of activation disappears. So as I mentioned, this effect is highly localized in the word form area, and it's short-lived. So the idea is if you activate again before it disappears, then we should be able to see any kind of behavioral evidence. So what they did was the following. So longer mask, forward mask here, 271 milliseconds. And then followed by 29 millisecond mask without any blank, 29 milliseconds of a target. Could be a radio, could be a cow or something like that, followed by another mask. And then followed by the target. This is a target. This is masked word. And then here the task is to say, and in this case, I think pressing the button, okay, pressing the button, mouse click, left click or right click on whether the target word was artificial or natural. And then they measure the reaction time for this task. And then what they found was the following on the bottom right, bottom left figure. So if the same word was repeated like this way, radio, then saying that, oh, it was artificial, was 605 milliseconds. It's very fast. And if it's different, it's 620 milliseconds. So there is 15 milliseconds difference. Okay. And then if it is the radio in the uppercase, there is this difference. But if it's small or a small capital or capital small, then this effect becomes slightly different. And still, whether the same or different word makes a huge difference. I mean, it's not really super huge. 607 to 617. So this is 10 milliseconds. So it's weak but highly significant effect of non-conscious processing. And still, people cannot actually here say that it was this. If you are asked about this in masked word, whether it was same or different, or whether it was radio or lion to false choice, to alternate false choice, the performance was again the chance performance, B prime of 0. So there, they basically showed that a very similar task and a very similar situation, as long as you activate the same location, before this activation by the radio, which is probably peaking at 140 milliseconds, the target is then presented, maybe because the previously activated radio sensitive neuron is already active, that activation to report that, okay, radio was artificial is faster. And that faster response results in this, 15 milliseconds or 10 milliseconds, regardless of whether this is a capital letter or, small letter. That's the priming result. Okay. So in summary of this part of the talk on the lecture, unlike the blindsided situation, normally, and I just presented Stan Dehaene's beautiful work, but it is I would say it's probably by default. By default, strongly masked stimuli are not possible to even detect and also identify, and you can't remember and you can't discriminate about chance. And accordingly, neural response for strongly masked stimuli are weaker and also short-lived. But the sensitive paradigm, such as the priming, can reveal a little bit of the disadvantage of this non-conscious processing. And this kind of study paradigm is necessary to demonstrate these weak behavioral effects. Okay, that's overall very different from the blindsided situation. Blindsided situation is much more robust in a sense and very puzzling. And that's what we are going to talk in the next video.